Hey, we're back with another special experience at InfoComm 2019 that I am excited to bring you along for. You hopefully remember John Huntington from when he joined us for the two-part video chat about his book, Show Networks and Control Systems. That's a book that I think everyone should have on their shelf for reference. This time, though, he has brought some friends, gathering after hours at the new Alcorn McBride shop in Orlando, Florida. This group includes folks from the biggest parts of the show control world. From the biggest theme parks, theater, touring productions, and more, these manufacturers, engineers, and educators are here tonight to talk timecode. I hope you'll excuse the production quality. The turnout was far more than we expected, and while we had Lectrosonics Labs for John and Jim, Baylin was left to chase the conversation with my portable recorder, so a huge thanks to Baylin for the help. Let's jump in now, everybody, with John.
I'm John Huntington. This is Jim Janninck. So this is our Geek Out. So this is a special one this year that we normally, I have a slide for this actually, I'll talk about in a second, but we're doing something a little bit different this year, we'll talk about in a minute. But first we wanted to thank our sponsors here. So Alcorn obviously is hosting us here and providing the Tiki Bar, which is great. Media One, which I think that's the correct logo now, right? So yeah, so Eric can tell you, but they just changed ownership Monday from Barco to some version of 7 Cents now. It's partnered with them. Eric can tell you the details. But Alcorn and Media One, whatever iteration over the years, have supported us on this thing, which is great. And then this time we have a special one. We have DcSoundOp here, who's actually going to record the whole session. And he has a great YouTube channel. If you're into sound, you should really take a look at it, and I ended up on a podcast there because I wrote him about, he did a great thing like on the New Year's Eve sound system in Times Square, and I'm like, this is really cool, and it's a type of information that's really not well documented in our industry, so it's really great. So he's going to record the session today. I have a mic, Jim has a mic. Baylin, who just graduated this last week from City Tech, so he's looking for a job, if you want. That's right. He's going to run around with the recorder and record things. So in the end, we do ask you to identify yourself if you're going to have something to say, or if you don't want to say, you don't want to be in a recording, that's okay. But just be aware that I think we're rolling now, right? So we're already being recorded whether you like it or not. Plus there's a camera in here somewhere. Got that. So hard to read slide, but we've been doing this for a long time. We actually started doing show control presentations back in the mid-90s. And I did a lot with George Kindler back there. And then we did these case study sessions at LDI. And George, unfortunately, people remember George died in 2006. And that year, I'm like, hey, Jim, we want to continue these things. I think that was the first year we did it. And then we did a bunch more of them within LDI. And then we realized that we were presenting to ourselves anyway. So we're like, hey, we should just do this for free rather than have LDI, charge everybody and do whatever. And since then, I think we've done 1, 2, 3, 4, 5, 6 in that format. And then we didn't do one last year. But this year, we figured we'd do something different. Rather than, those were like brief presentations on a real project. We might go back to that in the future. Those were really fun. But I think this year we want to try something different and talk about time codes. So time codes have really been sort of in the zeitgeist of our field a lot the last couple years. And then at IAPA this year, like everywhere Jim and I went, we just talked to people about time codes. We're like, let's do a special geek out about that. So we have 5 minutes of PowerPoint, and then it's really a discussion that we want to hear from everybody as a whole from the industry. We have a lot of representatives from various sectors of the business, and we want to hear what you're doing and what you need, and we'll talk a little bit more about that. So I'm a professor of entertainment technology at City Tech. I wrote this book, and if you just came in, put your name in, and you want to copy the book, put your name in this little red bag, and we'll pick it at the end. I'm a Local 1 member in New York. I wrote this book, obviously. I'm a subject matter expert for the ETCP certification program, which a lot of people should do. And then I've done a little bit of everything, film projection, concert tours, theme parks, Broadway theater, regular theater, not-for-profit theater. And then for the last almost 20 years now, I've been teaching at City Tech, and I still freelance around. But our sort of best known thing is we do a haunted house that we have 6,000 people a year come through. That's all run on Media One Manager, and actually has some Alcorn components in it too. All networked, everything. So come see it. It starts 7 days before Halloween, runs straight through. come see it because you can look at everything.
No time code though.
No, that's right. No time code. Yeah. So now let Jim introduce himself here.
Right. Well, I think I know a lot of you already. There's a few I don't know, but I've been in this business for amazingly 30 years now. Started with themed lighting, theatrical lighting, moved into actually working here at Alcorn from 94 to 99 before I started my own consulting company. I've been doing that now for 20 years. So a lot of show control experience, been in parks all over the world, seen a lot of systems, a lot of techniques, and I'm here to hear from you guys too of what you've encountered lately on your projects. How are you using time code? What holes do we need to fill? You know, we're going to talk a little bit about this SMPTE TLX effort that's in the works, because the SMPTE organization themselves are looking to update the 50-year-old longitudinal time code standard. So we'll turn it back over to John to.
Yeah, so I think the group is much larger than we expected, so I don't really want to go through the whole thing. But if we do just sort of show of hands, who works, you can only pick one. So we'll say theme parks, concerts, theater, whatever you do the most. So who works most in the theme parks? Okay, good. How about concerts in that area? No one, really? Theater, like corporate events, the staging and that. And what did I miss then? Oh, museums? Okay, good. I think you raised your hand twice though. And anything else I missed? Great. And I think we'll skip this because we're just going to talk. But as we go through, again, if everybody's welcome to contribute, we're going to kind of moderate, but just please identify yourself, who you are. So how many are currently using, and here's all the options, we'll go through it. How many, and this you can raise your hand more than once, but how many using LTC now? Okay, good. Vitsi, does anybody use Vitsi? Really? Oh, hey, how are you? Dave's using it back there. So, how about MTC? Yeah, MIDI time code. Smart group. Who's currently sending time code over a network? Wow. Okay. So then, actually, I'm going to blast through the next thing I think, but then I want to know how we're going to go around and ask how you're doing that. That's going to be our first question.
Because I think that's what we're all interested in, or not, yeah. Right? We're trying to move to networks. We're just looking for that standard that lets us all do so together.
So SMPTE, as you may or may not know, has been upgrading, or they haven't done it yet, but they've been working on, as Jim mentioned, is developing updating the very old SMPTE standard. That effort's called TLX. So Peter Symes, who's the acting chair of that, I guess somebody retired or something. They don't have a chair right now. They had a whole survey 2 years ago. They looking at how people are using time code and trying to address that. But SMPTE is primarily an organization for video and film, society, motion picture and television engineers, right? So that's where their real attention's focused. But they're interested in what we're doing. So one possible thing we can generate today is a wish list for them of what we want from that standard. Or we can say, well, we found a workaround, we don't need it anymore, something like that. So I think my objective today is to get some kind of consensus on that from this group, which is a pretty interesting, the people I know here are a pretty interesting group of people that do a lot in this industry. So we want to give them sort of wish list or say, you don't worry about us, one or the other, I think. So I got a PowerPoint from them that sort of explains their efforts. And I think I'm not even really going to go through in detail through the PowerPoint because to me, my reading of this, and if anybody, please correct me if you've studied this more than I have, which is probably anybody who's looked at it. There's not a whole lot in here that's really addressing our world, right? So their world primarily post-production. But of course, the time code's been around since the 70s. I actually have a book from a company called ECO that showed that they claim that some of the early stuff came from the Apollo missions to synchronize telemetry tapes. But it's that old. People as old as me remember time code on tape. Who remembers time code on tape? Is it only the people like 50 and older, I think, will get that. But yeah, it was made for, I think it's a really brilliant design, very elegant design.
That's why everyone is still using it today.
Yeah.
Yeah.
But really what it was designed to do is be read backwards and forwards on a piece of tape, polarity irrelevant,
self-clocking.
fast forward. Yeah, all that stuff.
Yeah.
But that's, who's using tape anymore? That's right. Is anybody? No. So everybody knows, I think everybody here knows the format, drop frame. Is anybody using drop frame?
Mostly.
Oh. Mostly?
Yeah.
Wow, okay. Well, you and Dave and like one other person, the only one, so. So this has been going on since 2007. Standards take a long time. And they had a task group to kind of move forward on this. So I just put up a couple of these slides, like what they're again, this is SMPTE materials, what they're looking at. Support of multiple media rates, integer, non-integer rates. Obviously, that's a big problem in video production. You have frame rates all over the place now. Very high, very low rates, variable rate acquisition, time span not limited to 24 hours. I don't think, not many of us are doing 24-hour shows, but it has been. Has anybody work on that Millennium thing in Times Square? They did that. They had to worry about how that worked. And then this other stuff, how to get in and out of this labeling stuff. So this is really what they view as their requirements. There's not a lot on here to me that looks like, in my world, I think like a multicast show clock that's reasonably accurate would be good enough for most of the things that I do. There's nothing on this list that says that, though, right? And then the standards manager told me they're kind of backing away from this a little bit as a priority, but I think it's something they really want, a very precise timestamp on every frame of video that's ever generated wherever they do it. So obviously if you're editing a big crazy multi-camera production, that's really important. If you're triggering some light cues, not that important. It doesn't really mesh with our world that much. Define mechanisms for adding new data field. I think Jim and I were looking at it the other night, like the word extensibility is in there about 100 times throughout the thing. So there is room in there to put other things in. And this is interesting, avoid substantive revision of the standard or start over, right? So we'll see. Extensibility, I actually don't even know what some of these acronyms are, but you can read up on it. Does anybody study this and knows any stuff? Please jump in if you have. So obviously it's some kind of header thing, you can carry it. It's supposed to be transport independent. Obviously in our world, the transport, in my opinion, is the most thing we want is Ethernet, obviously. I don't really think there's much else we're gonna need it on. And I think in general for us, like I think it seems to me that the time code we have is working pretty well. It's just kind of stupid to be running an XLR around when everything else is on the network. So that might be the minimum sort of thing that we need. So you get the idea. Again, there's really nothing in here about the way, and of course we were always a weird utilization of the standards, so I don't really expect them to understand our world, but they're really nothing, in their priorities aren't really even including us at all. And this thing, you get an idea, some kind of block header thing, et cetera, et cetera. Anything else?
That went fast.
I forget.
And I can send you the
tells the
PowerPoint
story,
if you want,
right?
but I don't
Yeah.
even know what all these acronyms are, so. But anything to add, Jim, on this? Or?
Yes, well, this is just trying to define how they want to package the new, well, in the old standard, the longitudinal timecode standard, it was super simple. It was binary coded decimal. You had one digit for the tens of hours, one digit for the ones of hours, and then minutes, seconds, frames. A few fields to throw in some user data bits if you wished to use those, which they left undefined. A couple of flags to tell you if you were doing drop frame or color video rates. This is similar in a way, I guess. They're just trying to define a label which contains data fields. And one of those data fields could be a timestamp, much like the hours, minutes, seconds, frames timestamp that we're used to. But they keep talking in their standard about extensibility. That was something that was not really available in the old standard. There were those user bits, but there were so few.
There wasn't a lot of bandwidth available for that.
It wasn't, yeah, with 80 bits per frame. So this one, they're basically saying, we want to define tags, metadata of some kind, so that if people want to add, what's the name of the camera that this video came from? And what was the exact time of day synchronized to the world's atomic clocks that this video was shot? What frame rate were they shooting at? Maybe even what resolution, what GPS coordinates was the camera located at? Whatever people think of in the future, When they talk about extensibility, that's what they mean. They want it all to be able to be fit into a TLX label. And they don't want to paint themselves into a corner, which in some ways seems to be delaying the creation of the standard because they kind of want it to be able to do everything for everyone. I think some of the advantage of the old standard was it was so limited that they were able to push it through and everybody just used it. You know, it was easy to understand and easy to write software for it because there wasn't a lot of extra. So yeah, they're adding layers like these profiles that were mentioned briefly because they realize, wow, if everybody starts making labels for this, that, and the other, and all of a sudden the timecode label is this gigantic thing and there's no equipment out there that can read it. So now we better define some profiles that say, okay, if you're operating under this profile, you're only going to send the name of the camera, the time of day, and then the receiver can read that. But now you've got profiles that receivers have to deal with. So yeah, we'll see where it goes. It almost seems to me it's getting too complex in some ways.
Yeah, and I would say in 25, 30 years of studying standards development, and actually Jim Kellner is one of the people who like changed my thinking on this years ago, but these things, I was like a big advocate for MIDI show control in the early days. It was kind of like do everything for everything, and now I think, again, Jim said some of the years ago about this, like it's not really the way, A, it's not going to be successful whether you like it or not, and B, you really got to focus in on something. And I have a section in the book that I talk about attribute of successful standards, in my opinion. And usually they're things like what Jim was just saying, they're very narrow, focused on one thing and do that really well. I've seen repeatedly these big, massive standardizers, where it's ACN in the lighting world, AES, I forgot, but it's now OCA, and that's an old friend of mine. I just saw him at the show. I just don't think it's going to get anywhere because it's just this huge thing that does all kinds of things for everything. And it just looks to me, without a lot of evidence, that this is the path they're on right now. And it seems like their standards work. There's been some, staffing issues and whatever in SMPTE, but it looks to me like they're heading for that sort of again, and it gets too diffuse and doesn't really get driven by anybody. And you see those efforts like ACN eventually got driven to completion by ETC, so that's ETC Net 3, but it doesn't connect anything else, so there wasn't much point to it. So the people in the back, we got at least four seats up here. We're going to be a while, so unless you like to stand. I know I've been standing all day. So I think I would say, and there's a webinar on TLX if you want to watch it. But again, I think you watched it as well. I looked at this stuff. I'm just not seeing anything for us in there. So we can tell them what we want. They may or may not include it. But I think what I'd love to do next is, again, the rest of the time now is really just a discussion. I think I'm just going to try to make a list of the people that were saying that they were sending SMPTE over the network. I want to know how you're doing that. So we'll just do a little, and then we'll see if there's lots of people doing that stuff. So people that said you're sending timecode over network now, how are you doing it? What techniques are you using? And then Balin's going to come to you with, what did you say? UDP?
Just UDP over ASCII that mimics what the current frames look like. It's just hour, minute, second, /frame.
And who are you?
Mitch, Smart Monkeys.
And that's something you guys wrote, so you're just doing it?
Yeah. So we sling it around between QSys, Medialon, and a few other custom things that we write.
And then if I want to extract it from your system and plug it into a whiteboard, how do I do that?
If it acts to go over the wire as LTC.
But what hardware are you using to do that?
QSys normally.
Oh, QSys, okay.
Yep.
Just a question for you. Are you including frame rate with that? Or no?
Basically our systems usually are standard frame rate across the board, so we don't need to worry about conversions, and we just assume that it's this.
And do you find that there's sufficiently low jitter and messages come in on a regular pattern that you can trigger events off of it?
For the most part, I see less than 0.5 millisecond variation. And like Jim was saying, it's not really any difficulty in our industry. And anything that does need to worry about being locked to clock usually is soft locked to the incoming anyways. So it's not really that much of a concern for us.
Are people, on a tangent, still distributing Blackburst or other forms of sync clock to keep devices.
All the time.
All consistent.
Yeah.
Color video sync or blank burst signals. If you need to frame lock stuff, absolutely.
Yeah, but that's not a requirement all the time.
Yeah, we're curious on a side path to timecode labeling is also the question of system synchronization and whether we can move that to the network utilizing things like NTP or PTP to establish a common clock for all the video and audio sources and projection equipment.
But I think that might be a good topic for next year, I think. But is that something you'd be willing, could you write 3 sentences on that and I can throw it on my blog or whatever? Or do you have some code you'd be willing to give away and put you on the spot?
Sure.
Let me ask you something. Is this over like a really busy network, or this is like a really empty network?
We put that over a network that has Q-line traffic across it.
Okay.
So we have no
'Cause
problem.
that's a really
with that.
small deviation from like the.
But that's 5 millisecond variation, so it could
No,
take.
0.5 or 5.
Sorry, 0.5 millisecond variation.
Okay.
Now, but that doesn't necessarily mean it gets there in 0.5 milliseconds.
Okay.
It's just it's never really varied in that. But we use switching that is wire speed the whole way. That has
Deep queues, yeah.
deep queues and stuff like that. So
'Cause I mean, I'm assuming like latency between the packets would be like 2 or 3 milliseconds anyway. So
but that's the latency to get there. But it's
Right.
never more than 2.5
but
milliseconds.
you can never
or less.
guarantee it's going to be 3 or 2. So like 0.5 becomes half that, right?
But they're all the same, so you can account for it. But we're also talking a tenth of a frame at 30 FPS at
yeah,
this
that's
point.
true.
So it's well within my considerations.
Right. So what were some other people that were sending over network, what approaches were you using?
RTP MIDI,
Oh, RTB Mini.
it's MIDI timecode.
And I think that's what the KISS box does, right? So you're just taking MIDI timecode, encapsulating RTP MIDI and using that to send over the network, right? Right. Other approaches?
We had a Rube Goldberg on a recent attraction.
Oh, right. Through Beckhoff, right?
Yeah, I told you about that. Longitudinal timecode comes in from the audio department. We had a Beckhoff PLC that needed to read it. Didn't have a native timecode reader interface at the time. So it went through a timecode converter, an Adrienne timecode to ASCII text converter over an RS-232 serial port into the serial port on the PLC. Some custom code to read that, and then it went over a network because then it went over Beckhoff's EAP, Ethernet automation protocol, to another processor in another equipment room that ultimately triggered queues based on it.
And that's how we did it before QSYS.
You used EAP as well?
We used an Adrian card with RS-232 into Moxa over to the network to, yeah. Yep.
Or the stripalizer.
Yep, that too.
Yeah, there's still distripolizers all over the place, mainly as confidence monitoring, because it's nice to have a big rolling display that you can just see, oh, there's my time code, right?
Any other approaches? We heard one today that I hadn't heard of it. So and unfortunately, Richard Bug from Meyer just emailed me, they're not going to be able to make it, but they said today, and after Steve Ellison and Meyer, we went to their presentation today, said they're using OSC to send time code over the network. Has anybody done that? Eric, how do you do that? Is it built into MediaOn or is it?
No, it's just OSC. So you give it a path, and then you're just giving it a value.
But you just update it every frame or something and propagate it?
Yeah,
That's UDP ASCII
it's
basically.
UDP ASCII.
Literally.
It's the same thing as what Mitch is saying.
Oh, okay.
With more steps.
Yep.
Cell or byte padding and all kinds of crap around
Right.
it. Yeah.
So then we kind of went on a tangent with that, but I think the other questions we had was, go back to PowerPoint mode here. So a lot of, in the old days, you couldn't really even conceive of just starting 2 systems and letting them run because this thing's going to run at 101%, that's going to be at 97%, they're going to drift out. But a lot of things today obviously have much better clocks than we used to. So it's certainly possible just to start 2 things and let them run wild. I know Universal Studios actually does that a lot on their attractions because I just taught a class over there the other day. Any thoughts on that? Anybody have experience with that? You're just starting audio and video, let them run, go and let it go.
Yeah, actually, some of our bigger systems do that as well. Multiple video players, you just hit go at the same time, as long as they are clocked.
As long as they're healthy.
As long as they're what?
What's that?
As long as they're clocked?
As long as they're clocked together with a black burst or a tri-level, then we can just let them run for hours and they go.
But then you're like blackbursting, genlocking them together. So
Yeah.
Well, I find on short duration shows, like a lot of theme park rides, you're only going to be in the scene for 25 seconds. You can wild run things in that scene. They're not going to drift out within 20, 25 seconds.
And has anybody? I mean, I haven't done it myself. So has anybody?
That's in Florida though. Like if you go up north, one is sitting, one is sitting in a really hot room, the other one's sitting outside. You're gonna get that temperature.
But has anybody done this and seen things drift out of sync in recent years? Is that still happening, or? I haven't tried it. I mean, to me, I'm old, and they're like, oh God, you can't do that. But the computers are a lot better than they were. So.
Yeah, I've actually done a lot of that because I end up doing a lot of low budget, like extraordinarily low budget, one-off, video with live music kind of things where it's mostly stills with a few cues that have, 30 or 40 seconds or a minute of motion, mostly where approximately in sync is good enough because there's no lip sync or, so long as I'm about, not drifting enough that it feels like it's not on a beat, it's fine. And I mean, I tend to do that with several QLab computers and just sending MIDI show controller OSC and just starting things at the same time and basically not bothering with time code.
And it can boil down to the equipment you're purchasing too, right? Which may or may not have been specified by you. Is your piece of gear capable of varying its frame rate to stay in sync with the black burst? Or can it just trigger and it has to follow its own clock?
I've run across stuff that has time code that can't vary its frame rate.
Right. It may input time code. Yeah, and it uses it simply to trigger and does not use it to clock.
And the old days, like it used to be, if you jumped around, it wouldn't necessarily, sometimes you locate somewhere else, it would just keep clocking along with the old thing, but I haven't seen that much recently.
Sorry, it's almost like this is two separate topics. Time code to reference where we are, but then clock to reference how often it happens.
Mm-hmm. It is two topics, yeah.
So
it's clocking and it's frame identification. Labels that name the frames. That's time code.
Exactly. So to think about, do we need time code anymore and letting the systems run wild? Those are really two disparate things.
I mean, really, a PTP with an ePIP is the ultimate.
Yeah. Well, that's what PTP is basically.
You got a thing that's supposed to happen either now.
Letting systems run wild during normal playback is fine, but get in the production environment where you're jumping around.
Right.
It's useless.
Yeah.
I mean, you have to go back to the beginning every time, and that's just counterproductive.
So I did a parade like that, and it was horrible. So during, if you only look through the lens of show playback, letting things run wild is pretty good. But if you have to commission a system, do a rehearsal, that sort of thing. And then there's another lens in the theme park world, which is if you fall, how do you recover from that fault gracefully? I want to jam sync back in, or do I wait for the next contact or edge trigger? So that's, I would say, running wild only works through that single lens of everything's perfect and you've already commissioned a show.
Yeah, or the show is short enough that you don't have this problem. A 30-minute theater show is a whole different case from a 20-second dark ride scene.
But I would even say running wild is slightly different because you can trigger in the middle if you know where you need to trigger, and then it just goes on continuously without re-referencing the code. So we can even have a mix of that where systems could possibly slave to that incoming time, or they could know, I should be at this time, so I'm going to trigger myself where I need to be, referenced to some immediate abstraction, and then keep going wild.
It seems like you have to keep track of time on each device.
Yeah. Well, because jam sync can cause its own problems, right? Because you're used to seeing glitches in the timecode stream, and some things can freewheel through them and ignore them. Some things, like one frame comes in decoded wrong, and all of a sudden your video jumps to that frame and jumps back, and you've created bad show.
Yeah, I had a project actually at Radio City where, I won't name the manufacturer of the device, but timecode came in, we got converted into RTP MIDI frames, and they arrived out of order into the laptop. And so the operator was like, the timecode's glitching. I'm like, what are you talking about? So I had him send me a video, and literally you see the counter go like that and keep going. and it would miss cues because it would jump right over the cue and not do it, and that we got that fixed, but it was that was like crazy because just arriving in out of order in the network.
I'm counting with 7 cents. So you've got this event that's meant to happen, whether it's the next frame of video at super high frame rate or it's spaced out events like a lighting cue or whatever it is, as long as everybody's got the same ticker. And you can buffer ahead maybe even to say this event's supposed to happen. You got this job to do. Get ready for it. Be ready for it.
Oh, you know that's coming, right? You can do it.
Yeah, I mean, usually it'll happen like, well, I got to do the job now. Like it's coming the very next tick. That's most likely the case because it's real-time control. But maybe you can say ahead of time, you got these jobs coming up, and until it changes, even if you jam synced, everybody knows their job, whether it's a frame of video or a lighting event.
Well, that's how parades work, right?
Yeah.
You're saying at this time do the thing, and that way their independent clocks that are synchronized to GPS or whatever it is, they run ahead, and when they run into that time, that's when everything starts, and then all these disparate machines, these disparate floats, start running their show at the right time.
And they're wild at that time.
Right.
After that go, they're doing their thing.
They're synced within themselves, but they're wild against the clock.
Exactly.
And it's so critical to the packetized lifestyle these days in general that things are going to arrive out of order. But you're telling them, do this at 5 o'clock, do this at 5:01, and they know when it's 5 and 5:01.
And that dives.
They do it in the right order.
Yeah, and that dives straight into your third bullet point there.
Yes. But anything else on any other comments on running wild, or anybody not know what that term means? Please, if we're talking about stuff, we kind of want to keep moving, but we want to define things. But
Tim Sweeter, I used to work with Birkin Engineering. I'm currently with Steelcase, so I'm a little bit out of the industry. Not many time code things in the office space, but when I think back to some of my experience in the industry, we did like the crane dance show in Singapore, right? And so it's this giant show action equipment, these giant things that were kind of like cranes, but were supposed to look like the bird crane.
Yeah.
And that's running off a Siemens PLC and just giant hydraulic actuators, things like that. And you're totally in that show action equipment world. You might get that go signal, and there's no way you're syncing to time code. It's like you program the set motions, the movement points, you tune the PIDs and all that stuff, and then eventually you program everything around the way that the show action equipment really moves, right? So time code can't exist in that. It was like a hit it and go kind of thing. You have scenes and you checkpoint in, but in that case, we weren't going to do like the Rube Goldberg that you mentioned.
Right. Plus, you had the opportunity to, because it was cue-based and you could chop your show up into shorter segments, you could rewind, jump in the middle, do rehearsals, and not have to go 30 minutes back. Yeah.
The only kind of time code stuff that I usually run into, and that's what I think I'm hearing over here, is usually in the parade or the fireworks show. Anytime I did Disney or Universal stuff, it's it's the 20-second dark ride frames, or it's the Disney animation system that's just looping through their scenes and things like that.
And I guess there is a subject of the difference between world time or atomic clock time versus show time and the offsets that are involved. Like Eric mentioned, you could just get some nice GPS receivers. GPS satellites broadcast a very accurate time signal. And then you know what time it is, but you don't necessarily know what time your parade started. So I'm curious, how do you load in the offset? Like, do you do it right at the top of the show to say?
Basically, you loaded an offset at the top of the show, and then you're basically constantly calculating minus the offset, and then that's where your show timeline should be.
Yeah, so then you can take the benefit of a GPS clock, but also use that all my cues start from the 1 hour mark to the 1 hour and 25 minute mark.
Right.
Yep. And then that's something that in systems, I'm comfortable even preloading all those to say, okay, at this time wall clock, essentially, I want you to start these things, and then as far as I'm concerned, it'll do its job. If that means 1 hour, 2 hours, 24 hours, or 60-hour mark, if we want to go crazy, it's 18 frames offset, it's 36 frames offset, or better yet, it is 1800 milliseconds offset. So we can kind of start segregating ourselves from the idea of a frame is the reference instead of I have a video that lasts, or I have a video image that lasts 16 milliseconds.
It's super high resolution tick, and then we can dumb it down to what we need there.
Yep.
If we need 30 hertz.
Right. I think that's the subject of the second bullet point there, right? The latencies that we need on some of these shows. You know, there's a lot of video and film work. It's at 24 frames or 30 frames per second, but there's other show systems that need a much finer clock than that. Like a very elaborate water fountain show comes to mind, where you might have 100 jets across the stage and you need to walk through them from one end to the other over a 1 second period of time. And if you just did it at a 30 frame rate, you'd see the jaggies in it, right? So then
you know, it's water.
It'll be like steps.
No, I'm serious. Like, are you going to notice when two jets come on at the same time, right next to the
Those valves actuate really fast. So.
You do.
Behind
Wet actually does it a lot.
Yeah.
NAB had this really cool water show. I forget the company name, but they literally like printed words in the water. Yeah, so it literally is the same thing.
now you're operating like an inkjet printer.
Yep.
Yeah. But I think that comes back to what we were talking about with the show action with the PLCs. If you need that accuracy, why don't you not worry about the entire industry being able to have that accuracy, and rather just this specific thing have what it needs to do, and then the rest of us can have the thing that's much easier to use, much cheaper to use, and is good enough.
Yeah, SMPTE in their TLX effort is trying to address this by just using a super fine clock. They're going to just adopt the PTP.
The simplest job can use it, but it's accurate enough that Mitch can use it.
But yeah, I think that's just that fine line. And one of the things that I did like when I was reading about the TLX was the fact that they were using that standard clock, and they could just subdivide it however they wanted to.
Yeah, they've got it down to the 4 billionths of a second level.
Yeah, it's basically GPS time.
Right. It's PTP timestamps. There's like, what is it, 48 bits worth of seconds and 32 bits worth of fractions of seconds. So that's 1/4 billionth of a second.
The whole world is synchronized to this clock.
Yeah.
Yeah. Well, that's true. That's what the atomic clocks put out. So.
But I mean, despite what Ken says, I actually don't think we need that. So I think we can find a middle ground that is much cheaper to do.
Well, that's actually our sort of next question here. But just while we're thinking about PTP, is anybody doing anything? I mean, besides like word clock kind of things, but are you using it for show timing or?
Yeah, just name your name. John Helfrich. I'm with Beckhoff Automation, actually.
Now these guys know.
Yeah. So we use PTP to clock all of our I/O and across distributed networks.
And I think like what Mitch is saying, that's more, it's like within your system you're using to clock it, but you're not, are you triggering like lighting and sound and things like that against it? Oh, okay. Just in your scripting inside.
Yeah, we'll do it through our the EtherCAT bus, because you can lock all your I/O down to like a 2 nanosecond window, and then we'll trigger our effects off that. So there's some parade systems that use it right now, but actually one of the water effect shows uses it for that to print in the sky kind of thing.
Oh,
high resolution.
Yeah, because you can get down to like 10 microsecond triggers, but yeah, the propagation delay is about 2 nanoseconds jitter. So
what was the propagation?
2 nanoseconds.
Oh, nanosecond. I thought you said 2.5 seconds. That's like fireworks pre-firing.
Can I ask a fundamental question? And so I'm not a
sorry, just name it.
Tim Eck with Universal Creative. The transport and the protocol. So GPS is awesome, PTP, that sort of thing, atomic clocks. What I'm curious about is how is this encoded to the media? How is it quote unquote striped? So, I can run certain animatronic systems off of a iPod Nano with left and right stereo split, just to test it in a shop. It's kind of cool, right? So, are all these other systems assuming that the media is not the master? There's a master that is now triggering the media as a slave. So I'm just curious, is that a topic worth discussing? I'm just curious what's master, what's slave, and how TLX even is solving
I mean, sort of traditionally, there was, the way it was, what it's made for was it recorded on one tape and then have another tape and it would synchronize it. But I think you see all different architectures now where sometimes, I was just having this conversation with somebody today and I talked to too many people, don't remember who it was, but talking about the, that in that, whatever they were doing, they were just literally recording the time code as an audio track and putting it out. But obviously otherwise you could have a separate generator that then drives everything else. But any thoughts on that for anybody?
The way I think of it, these standards, shall we call them, it's just a unified way to name frames in the case of the SMPTE standards. It's a frame of video or a frame of television image. And we want to give that frame a name so that we can talk about it together during editing or post-production or playback. How that frame, that name of that frame is encoded on the material. In the old days, it was the audio track striped or an optical track striped on the side of the film print, right? These days, they're trying to move it to Ethernet and embed it in the metadata of the video, I suppose. They don't actually address transport or how you store it. They just address, here's what the bits are going to look like to name it.
It's fundamental that I didn't see that on the TLX.
Yeah, TLX aims to be transport agnostic. They're not going to define how you store or even how you send it.
I doubt there's a way to record an analog tape, though. So.
No, they're not going to do that.
So, like walking the show, there's a lot of people that still have an analog hole, if you want to call it that. That it quickly goes to some dongle and transports it to USB or Ethernet or that. So that's obviously the lowest common denominator, but is what are the methods other people are using to? When you took those notes on Notepad, I'm curious, is that still using an analog hole?
So you're saying taking the actual LTC audio and recording that as a track, which gets insane because then we're digitizing, but who's doing that on shows now, like recording the time code?
Well, maybe not recording it, sending it over a radio signal.
Right, radio, yeah. So it's effectively analog. And what was that?
Or we generate it and then immediately turn around and digitize it.
Right. But is anybody, if you're doing a show, are you sticking on an audio track typically, or you have a standalone generator or something like that? Who's doing it?
Typically speaking, everything we're doing is it's always tied to an audio track for everything we're doing. I'm sorry, Eric Boxer, Walt Disney Imagineering. Everything we do is tied to an audio track, and so it just sticks to the audio track, which is interesting because it gives us the ability to do multiple frame rates. So where our audio could be at one frame rate, our time code could technically get a different frame rate, and that actually has caused some headaches for us in the field. But we're getting more and more where we're digitizing that. We have taken audio that has been recorded off of a generator somewhere, throw that into a KISS box, and now it's on the network. Now we've got the RTP MIDI that we're dealing with, or we've got it going directly into devices. So it is still, for us, some way that it has to be synced, it has to be locked.
And we've actually encountered the opposite problem where it was striped to audio and it was too limiting on the show because we'd need to immediately let the audio keep rolling and then jump into the next scene and prep, essentially have a 5-second pre-roll so that lighting could prep for the next scene. So we intentionally had to decouple it at that point. So there's the idea of it being tied to the audio was a problem at that point, and it was like, what do we do? Because up until that moment, it was, tape go, and it's just striped along with the audio.
And that could be a problem for parades too. If you're having a parade loop, how do you treat a loop?
Right.
Yep.
I think in the end, Stefan from I think in the end it's also
just a little louder so they can hear you in the back.
I'm sorry. I think it's also very product specific because basically where you want to put the generation of the time code also related to the media or what it is, the source.
And department politics too.
Right. Yes. Basically, if the audio in your show is not very important, you may not want to put it there because if the audio goes down, you may feel like it's good for the show to keep on going, but now you're stuck with not having any time code anymore. So you may want to have the time code somewhere else.
Yeah, I think in those type of issues, I'm like asking, I'm just sort of trying to get a sense of what people are doing, but with the understanding that there's no one right way to solve these problems. I think that's been obvious already. The whole nature of this topic. So, anything else on the PTP, the running wild? Because I want to kind of the accuracy thing. I think is kind of interesting, but anything else, any related to that? So, and just name and identification.
Scott from Alcorn Bride. The cool thing about PTP is it kind of minimizes that whole running wild thing. Like our systems, we actually take that and we regenerate our show control clocks and even our AV clocks based upon that. So it is effectively a gen lock replacement for us in a lot of ways. Aside from that, like I like what you said, Mitch, about having like a sequence of events kind of scheduled based upon that PTP time. The only issue we have to solve there is what happens if that series of events stops, like Tim said, like a rehearsal or a parade loop. What standardized control signal do we send to restart that process, cancel those scheduled events, and then reschedule events based?
Or slip a new offset value in.
Yeah, to me, the holy grail kind of sounds like PTP, NTP. There's no need to reinvent the wheel there. That's how we keep things accurate, and we know what the real world time is. It almost sounds like the holy grail is let's send an identified clock that references PTP time, so that we know that
like a show clock
time 1 minute and 2 seconds is actually PTP time 1 minute 2 seconds, or 24 hours through like the full blow thing. And there's an association there, so that we can internally kind of regenerate based upon the PTP clock.
And that would actually tie in with SMPTE, the LTX standard that they're looking at, because if they start relying on PTP and that date of birth, this idea that they have in there, they just say absolute time. So when I'm assuming when they start working with the editors and the video editors, Pro Tools, Avid, and things like that, they're going to say, well, I need to play back this sample at this specific time, which is referenced to wall clock. So they're really going to be regenerating their time code, translating it to be a reference to what you see, but they're going to say it at this moment in time. And exactly what you were just saying, Scott, at this moment in time, we know what needs to happen, so let's just reference that.
And yeah, if we did that whole kind of time code going out associated with PTP, your control signal would be, crap, the time code just jumped back.
Yep.
So I'm going to cancel all this stuff and I'm going to recalculate where it should be.
Exactly.
Yeah.
Exactly. You're not trying to figure out what the new ticker is. We're already on the same ticker. It's just the event is redirected.
Yeah.
Oh, sorry.
Andy Dolph, University of New Hampshire. I wonder if there's an opportunity to have some sort of options in how we work with this that could be standardized across manufacturers, that like we identify the concept of a hold or the concept of a vamp, so that we could say, okay, we know that at this point we go into a vamp while a performer is doing something that we can't count on the exact length of it, and then we cue out of the vamp at the end of the next loop or something. But that the time code, like there could be a flag on the time code that says, okay, we're in a vamp. And so now we're expecting that time code to keep coming around until we get a warning on the end of the vamp. You know, much in the same way a conductor would with a live orchestra.
I wonder if you just tag time, tag absolute PTP time, you really don't even need to say, hey, we're vamping. You just stop sending new commands. And then when you need to do the warning, you just say, okay, at this time up and coming, which could be 20 nanoseconds from now, depending upon your distribution, of course, then you just say, okay, we're warning and we're moving on. So we don't need to be linear anymore. Think of that type of aspect to it. You're just saying, at this time, do this thing. At this time, do this thing. Humans, we need to have some way of looking at that. Hours, minutes, seconds makes sense. Possibly frames, possibly thinking of something like milliseconds. But when you're going through your cue sheet, you can just say, oh, here's just a big red line that my show system is going to stop sending new commands. And all the other systems, when they won't get commands, they just won't go anymore.
With VITSI, didn't they just keep sending the same time value?
Yeah, it was called idling. You would send the same frame symbol over and over and over and over again. That was called idling. So it wasn't a dropout in code because you were getting valid code. And since the code is self-clocking, you could continue to clock off of it. But the frames weren't advancing, so your media would kind of freeze. Yeah.
Idling actually is it's something we definitely do need to address.
So I think we got about half an hour left. The one thing that just occurred to me is we have a bunch of different people from all different companies and backgrounds in here. But I think one thing would be useful just to make a quick list of what are we controlling today that needs time code, because in the end, if we come up with some new thing or SMPTE does or whatever, then obviously all the lighting console people would need to do it. I just looked at the new Grand MA3 today. It still has an XLR time code on the back, but it has a network jack, so you can get these things. But those are the people, and the video people and whatever, that those are all people that would have to be convinced to do this thing. So that's the other part of it. Or the other approach is, like in the lighting world, and being a sound guy, I beat up on lighting people all the time, but they're still using DMX. I don't think DMX is going anywhere anytime soon, but they're usually distributing it now from the console out to a local point as a network, and then the last mile or the last yard is old school DMX. So it might be something like that. Might make sense in here too. But first, all the obvious stuff. So we've got like lighting console, because I want to send this to the SMPTE people and say this is what we're talking about. What other types of things are you controlling?
Obviously video and audio.
Video, playback, audio playback. What else? Animatronics. Pyro.
The show controller is not the master, it needs to receive it.
Right, show control itself. So what I missed, whoever said that? Oh, haptics. What else is on our list here?
Special effects.
Like what?
Show action equipment, but also atmospheric effects.
And then at the end of this list, I'm going to ask a different question. Fog. So it's like everything on the old MIDI show control device.
Looks like everything in your book, right?
Yeah, that's right. So, but the next question I want to ask is control. How many of these things, and playback, I just invented a new word, but how many of these things are we really, like, every lighting console I know is just using that as a go time, right? Once it goes, that cue is basically running wild against the clock. So even if the frame rate varied or the time code stopped, that cue is completing. So that's really an event-based trigger, but that's not what timecode is designed for, right? Timecode is designed to servo audio and video tape decks. So is there anything on our list today that we're really using it to servo anything anymore? Or are we just doing event trigger? Animatronic, video deck. So, what's up?
I don't know, you might disagree, Bob. So animatronics, you want it synchronized to a finite frame. I don't see anybody doing a servo loop.
Right, but then it's really an event trigger, right? You're doing the arm movement or whatever. But I mean, usually most animatronic software is some kind of timeline. But I have a feeling, I don't know how, this is like what I think Jim was saying before, that not every manufacturer is really reading every timecode frame and acting on it. But obviously pyro, there's no slowing that down. Show control is sort of a different thing. Haptics I don't really know about, like in terms of, are we doing any ongoing sync from that?
Basically preloading the cues.
Yeah, it's still an event trigger in the end, right? So, cool. So, because we got about half an hour left, and I definitely want to write up sort of a wish list here. Oh, captioning, yeah. So it's kind of everything on a show. And we could have another hour of philosophical discussion about why we're using timecode at all, but I think that would take too long. But
sorry, I'm Adam Rosenberg with Alfred McBride. If we're going to make a wish list, I would love to see a standard transport. Like you were saying that they're not going to define a transport, but it would be really handy for all of us to be able to communicate over, like, let's say if it was UDP, I don't know if it's going to be broadcast, multicast, unicast, what port it's going to be on, any of that stuff. And it'd be great if it was a standard.
Right.
Yeah.
So let's hold it up for 1 second, just do this last thing on the slide here. So how much, again, we're not talking about in a subsystem where you're servoing a robot or something, but as a show clock, does anybody want to put a number on what's sort of the minimum accuracy we would need for that? 100 frames per second? 30 frames a second. I mean, most of the shows I'm involved with is like 30 frame non-drop. That's fine, right? And then if you need more accuracy, you trigger something and it handles it.
30 a lot in audio, but you almost never see it in video.
And they still have insane frame rates over there.
2997.
Yeah, which I don't understand why we're doing that in 2019, but
I don't either. Well, I thought when the world went digital, we'd get away from that. It didn't happen.
I was gonna say, we use True 30.
you're using what?
We use True 30.
Meaning non-drop frame, 30 frame, yeah.
Hunter from Alcorn, your slowest tick rate in your shows is often your video. You know, compared to a pixel clock or compared to a sample clock, video is significantly slower.
The timing of the ticks is important.
Right.
Yeah.
So to get a gym lock, you need your pixel clocks, but in terms of show timing and getting close to that edge, your video frame clock is significantly slower. So the nice thing that we like about PTP is you're completely frame rate agnostic because it's so fast that
You can divide it down to any integer or non-integer frame rate.
yeah, you can generate any clock you want out of that.
For 1/1,000,000th of a second.
And SMPTE is defined, you know, from now to the end of time where every frame edge is going to be at any given time. So you can generate your 30s, your non-integer rates, and you know exactly when everything's going to happen.
Anybody object? How about different? Oh, sorry, I forgot.
Well, just to add to that, I'm Joseph with Crafted Design. One of the ways that we end up using synchronization clocks is to do audio synchronization and trying to do time alignment between two speakers. And the standard the standard unit for that would be milliseconds. So when you only have frame accuracy, or if that frame is drifting, if your frames are exact, then you can calculate it off of that. But having smaller pieces than that, so that you can offset your audio one way or the other to actually get enough accuracy that you can do proper audio time alignment.
So does that mean, like, instead of having a delay in your signal, you're just delaying the start time relative to your time code? Is that? I don't think I'm quite understanding what you're doing.
Well, just we do a lot of onboard audio on ride vehicles. So if we have the controller running the offboard audio and then the controller running the onboard audio are only synchronized via whatever clock you're using. So in order to get that onboard speaker time aligned to the offboard speaker, we really need at least millisecond accuracy for the start times of each audio trigger.
What do people, is that, for just asking the group, is that like an edge case, or is that something that should probably have a different solution, or is that everybody, because that ups the frame rate a lot.
It seems like it's a common use case. We've done the same thing. Oh, okay. And but it's more a matter of that is the source of your clock, not how accurate your clock is relative. Yeah, you know what I mean? Yeah. Like if you use GPS to do that, your source is accurate, so you don't need to worry about the accuracy of your frame within that source, or the accuracy of your labeling of what this time is and what this time is.
Yeah, it goes back to the freewheeling question. If everything is locked to the same and those frames are all coming at exactly the same moment, then you can just offset. And if they're not, and you're trying to freewheel, then having more accuracy is useful.
Exactly, but then to throw this back at PTP, it doesn't matter. Yeah. Because it's accurate enough and you can push it off a few nanoseconds and it all works anyways. Yeah. So if you go to that extreme, you've got all of your bases covered, but that's also more expensive.
But so the advantage, if the video rate is good enough for shows, obviously SMPTE's going to handle that, right? Because they're going to support all, whatever frame rates you're going to have. So if we end up staying with them and we do that, then they kind of solve that problem already, which makes it sort of easier. So if it maybe, I'm sure they'll have 100 frame, whatever, something.
The sensitivity of the events you're trying to synchronize.
Yeah.
LTCs work. Oh, sorry, this is Ken with 7 cents again. So it's all about the sensitivity of the signals the events you're trying to synchronize, right? LTC's been popular and worked for so long because the majority of events we're trying to synchronize are pretty sloppy. In terms of atomic clock accuracy. But video signals, we're not trying to synchronize. I want to be seeing frame one of this at the same time as frame one of this. The events we're trying to synchronize is when it goes from frame 1 to frame 2. So that's a much more sensitive signal.
And that comes down to, I guess, the labeling. Because you can't label every single nanosecond. Yeah. So really it comes down to how we as humans can interpret this high precision clock, whatever it is, if it's PTP, NTP, or whatever. How often do we want to have a label? What do we want those labels to look like, and what transport do we want to use for those labels, both at rest and moving across the wire?
Can we look to industrial automation systems? I mean, Beckhoff is a good example. They use machines that move way, way faster than humans can, and way faster than we can perceive. So they're moving things around and synchronizing moving events quite normally. So can we use that as a reference for ourselves? Because we're not able to perceive, as humans, we're not able to perceive things nearly as fast as these machines are able to move. And they are somehow able to synchronize their events together.
But I'm just saying, and you would then, if this could be successful, we would have to go to ETC and all the video players and everyone say, you need to take the spec off level 1,000 frame a second, whatever, or 1,000 tick.
I'm not saying that we need to use that. I'm saying, can we use that as inspiration for?
In what way?
To see how they do it, and can we dumb it down and make it cheaper on the silicon?
Oh, okay. So SMPTE should talk to Beckhoff and say, hey, you're already doing this.
It's all in the EtherCAT spec. And actually thinking about this, it makes you think, because there's so many different protocols in the EtherCAT spec. There's CAN over EtherCAT, Circos. But why couldn't there be like a SMPTE over EtherCAT, to where we actually already have distributed clocks built in to where you get that tight time synchronization? And the only thing is it's not switchable, like you can't route it. And
doesn't have to be.
Yeah, but every manufacturer will have to have like an ASIC level inside, and that's where it could get tricky, is having a vendor implement an ASIC that supports distributed clocks.
Like decoding.
But the advantage of it is down the line, TSN is going to be supported, and we're already on the front of that, trying to support TSN to where you have distributed clock switches.
I think there is still this discrepancy between how accurate you need your internal references to be and how often we label that these references go out. Because there's really nothing stopping somebody who needs this pixel accuracy to say, I'm approximately 10 nanoseconds after this label, this human label, which is what we would consider standard LTC right now, or I'm 5 milliseconds after this human label. So, and that may even get close to what we were solving before, of systems that need to be accurate can still be accurate, but these other systems that only really care about 100 frames per second, they can get this in and they can be lazy about it, they can be sloppy, and thus a lot less cheaper, not dedicated hardware, oftentimes implemented in software, and kind of solve the problem that they need to solve versus let these other systems solve how they need to solve it.
Well, it's the same idea as synchronizing to SMPTE devices using TriSync or something.
Bingo.
Yeah, it's the same idea where these ticks are exactly accurate to each other, and they're much more accurate than the labels indicate.
Exactly.
Yeah, what we're talking about replacing is actually, the combination of a black burst and LTC is incredibly accurate. Because that LTC, that black burst is a super accurate video pulse that's synchronized down to the pixel clock. And so when we talk about, and then you can align your LTC to there, so you're not getting labels very often. But when you do get them, it's super, super accurate.
And then you can synchronize to that.
So then in the video world, that lets us, pull that timing out of there. But in the control world, you have a little more slop to play with, a little more jitter.
It's only as accurate as the person who's identifying the clock. So, I mean, if you have a situation that's not as sensitive, you don't have to have such an expensive device.
Exactly.
They can have their basic PC system clock that's making some software clock based on it. It doesn't have to be atomic clock every time.
Exactly.
But the same protocols can apply. It's just a matter of a cheaper device produces the master clock.
So we got about 20 minutes total left. So can anybody want to propose some language? Because like I said, I have the SMPTE standards manager's email. They're working on stuff. They are the ones that made the existing standard. Obviously, we could make our own. We could go to ESTA and make one. You could go to AES and make one. Whatever you want. That's a lot of work. If they're already underway, they're going to make something. We might as well sort of ask them for things that'll help us. Does anybody want to propose language to send to them? Like, what are the 10 things we want in for show application?
Well, what Adam said, I think what we really want is a transport spec, so we can all talk to each other. They're talking about replacing our 80 SMPTE bits with a key value pair, which is fine, and we can all parse that and fairly easily. What we really want to know is how to get that label from point A to point B. Are we sticking it in video blanking? Are we sticking it in the UDP packet?
Right. I would propose Ethernet, obviously. Is that, anybody have something different? Or so they're going to be transport independent, but Ethernet's good, right? Do we want it layer 2, layer 3?
Well, the problem with that is that if you choose a hardware option to deliver information, it's going to be more expensive for manufacturers to put it in. So it has to be a software option.
I'm not sure what you mean.
In a sense, like if you go down to hardware level, we need like FPGAs to encode down to nanoseconds.
Like an Ethernet solution.
Yeah, you need like hardware.
Yeah, I don't think
so. But it has to be somewhere upper level, layer 4, layer 5, where you can actually encode it at the top of some physical transport that already exists.
And I think we kind of blew through the slides, but they do talk about their objective is to have an open source thing that can be implemented and some reference design and that kind of stuff, because obviously there's many manufacturers of video stuff in the SMPTE world that are going to have to deal with this, and they have the same concerns. But anybody disagree? Ethernet is our preferred transport? Nope. IP, I assume? We don't want layer 3, right?
From layer 3, you need to be able to route the signal.
Yeah. Well, I mean, ABB TSN's layer 2, and we just went to presentations last night about how great it is. It's going to take over the audio networking world, blah, blah, blah. It doesn't exist at layer 3.
Wasn't there another company that promised that they were going to deliver power, Ethernet, like video, audio, everything over one?
And you can read, I've written about 20,000 words on my blog about ABB and Dante if you want to read about it. But so how about UDP TCP?
Yes, UDP, because it has multicast and broadcast.
And we want either one, right?
It's
unicast or multicast.
You want everything.
It's UDP. It's whatever you target. You can make it be broadcast or unicast depending upon just how you target the address.
And stuff, yeah.
Well, it's application specific.
Yeah.
You know, we're talking about how show sync is a different issue, but once you have your common time base, even if it's like a glitch in an LTC signal, you can free run over any missed packet or something like that.
Exactly.
And in ACN, one of the big holdups in that took forever that is part of streaming ACN now is they have reliable multicasting as part of their structure. I don't know, is that something that's necessary here, or like multicast is good enough? Because that obviously adds a lot of complexity, and they had to invent whole new protocols and all that.
I think you don't need the reliable multicast. You just need multicast because you're going to replace that packet with the next one, right?
Well, when we get to that though, and we're talking about UDP, and we've talked about packets being delivered in different orders, do we want some sort of sequence? Do we want a known sequence number?
You're talking about acknowledgement?
The packet comes in and it says do this thing at this time, this label's at this time. So if you get them out of order, it doesn't really matter.
So like with SMPTE 2110, you might be trying to describe some instructions that are longer than a packet, 1500 byte packet. But so they order, you have the timestamp on each packet, but you also have an ordering of which order they're meant to be rebuilt in, because they got to rebuild it into the total page of instructions on the other end. And those are numbered with a segment from when they start, just a numeric number.
So larger data grams, I guess.
Yeah, which is just about everything is going to be larger than 1500 bytes.
Sorry, can't hear you. Larger what?
Pretty much everything that's packetized on the network is more to write than can fit in one UDP packet on most networks. So 1500 bytes is going to have to be broken up, rebuilt on the other end. So segmenting those with a numbering scheme is got to be.
And I imagine that's a problem they're going to have to solve in their world too. So, but it's something we want to. And if you don't know how these standards work too, because SMPTE is an ANSI-accredited standards body, so whenever they write something, it goes out for public review, and then everybody has a chance to comment on it. So whenever that happens, I'll certainly publicize the public review. We need people to read it and respond, because I'm involved in the ESTA group and the ETCP, and often people don't read the standard, don't get involved in the task group, and then bitch and moan about the result. And it's like, well, it was public review for like 90 days, and nobody responded, whatever. So that would be. So this is just sort of while they're formulating it, some things we can ask for. Anything else?
This conversation about like packets out of order, I think this is why the whole PTP, NTP, GPS side of it's so important, because if you get the SMPTE time and it's 2 frames in the future or whatever, then the receiving system should go, hey, I'm keeping track of an internal SMPTE clock based upon the real world time, and that message I just got was out of order, and that was so 2 frames ago. So I'm just going to make sure that I'm still at the correct.
Well, and the other thing is network latency. So if you've got a device that is right next to your master clock and it gets a 1 millisecond ping, but then you've got something that's across a part and through 6 switches, and now it's got a 20 millisecond ping, and you said, okay, it's now 1 minute 10 frames. it's now off by 1 minute 10 frames and you know, some time because it thinks it's the wrong clock.
From having read
PTP
through
fixes
the presentations about TLX, I think we might be barking up the wrong tree, unfortunately, John. TLX is not designed to address these synchronization issues at all. TLX, I mean, what TLX stands for is time label extensible. It's literally just names for frames. And it addresses nothing about when you receive the name of the frame. So.
But that is an issue in broadcast they're going to have to deal with. So, because they obviously
yeah, but
network stuff all around the
TLX is
world.
not the standard that will provide you an accurate point in time. It won't be useful to synchronize equipment. All it's useful is to identify this frame that you're looking at is the frame named 1 hour, 12 seconds.
Yeah, it basically says, at this moment in time in the universe, this thing happened with this information.
Well, this frame, it's like this frame came from camera B on this movie set, and it was this time that the frame was shot. It really punts on the issue of...
But they will have, like, post issues where they're syncing audio and video. They're going to have to address some of these issues. Whether they listen to us or not, who
they're
knows?
punting and relying on other technologies, such as PTP or NTP,
Right.
to
That's
synchronize equipment.
So what I wrote in here on that is compatible with PTP, NTP, time base. So that's something we want. Anything else? So the wish list, I'm just trying to get, again, these are just some ideas we're going to send to them. They could say piss off. They could say that's great. Who knows? The standard could be released next year, could never be released, we don't know, but if they're working on it. If they're going to do this, they might as well get a list. So all I've got now is Ethernet IP, UDP, and the reason for that is we want multicast or broadcast. Network reliability in terms of like TCP, not that important. I think people can disagree with this. How do they handle this timestamp address ordering? Because they're going to have to resolve that as well. And then some way that this thing is compatible with some other time base of Genlock, PTP, NTP. Anything else we want to add to this list, or anything we want to take off this list? Or?
To Jim's point, can we ask just to confirm they're relying on others to do the synchronization? Because the sound to video was a good point, John.
Yeah, how do we frame that question? Let's see.
I guess that's already solved by date of birth, though. If every single thing has this sample was done at this millisecond, you don't have a synchronization problem anymore because you know this frame started at this millisecond wall clock, this sample started at this millisecond wall clock, and then it's up to your Pro Tools or your Avid system to know, okay, I just need to offset all these playbacks from when I hit the spacebar to hit play on my edit console to when it was actually done in the real world. And you're in sync. It's actually a pretty ingenious way of doing it.
But they do have other applications in more traditional broadcast and stuff where they're going to have, live real-time things synced to a clock. So I think, but there's a larger framework, and I'm going to get the number wrong, but it's simply 2110 or something. They're working on a huge thing. They want to put everything on IP, and they may. I think parts of this will probably get doled out to that effort as well. Anybody just want to say, oh, go ahead, sorry.
That may sound obvious,
And sorry, just name and affiliation.
Name and... Olivier Smart Monkeys. That may sound obvious, but we may need to carry multiple timecode on a single network.
Oh, okay. Yeah, that's a good one.
I mean, SIP 2110 is obviously primarily focused on uncompressed video over packetized network, but it really handles a lot because it has standards that define ancillary data, which pretty much everything we're talking about could be defined by ancillary data. It's just events with a description of what the event is. The two devices know how to communicate the same language. So it's the transport of the language. Again, that's the tough part. Telling them when an event's meant to happen. What the event is doesn't necessarily matter to the standardization. It's best between the two devices to talk about. It's the clock. That's the only thing that's consistent between all of these things.
It's the clock, dummy. It's the clock, yeah. And then one thing about the standard that they're developing is it's binary based. And I don't know how far they'd be willing to go to make it so that they don't have weird checksums on it. They don't try to essentially cover for the discrepancies that existed in the past. Like RS-232 communication, you'd have checksums at the end of it. Well, we don't need that anymore. That's already built into Ethernet. So if we can make sure that they don't include those types of things inside of their packets, that would be great.
Well, I think, and I might phrase it as like simple and minimal overhead, something like that.
Yeah, because it looks like they designed it a lot. I did read it before. It was that that they designed it to be readable by embedded systems with dedicated firmware that knew how to read this in, convert it, and then send the electrical signals onto your red camera or something like that. Which works because it's binary, but it's dedicated firmware. We could implement it in software, but I really can't do that on a Raspberry Pi.
Yeah, talk about how extensible it is. I think it's important that they were talking about having different profiles, kind of similar to PTP. If we're going to be implementing this, I think it's important that we keep the standard profile as lightweight as possible.
Yeah, that's the whole idea.
And then if,
we keep it hardware?
Yeah, for different industries that need all kinds of crazy tagging, they can make their own profile. But you know, for us, we've gotten along pretty well with those 80 bits. We don't need a 100 kilobyte packet going around.
Great. So I think so again, the standards process is slow. We're going to send this in. We'll see what happens. But I do think as a group, as an industry, we should pay attention to what they're doing because we have an opportunity to piggyback on their expertise and their development. And like I said, they're very open to steering things. If they can accommodate us, they're happy to do it because they know we exist. It just is anybody here? I'm a SMPTE member. Is anybody on the committee? Right, so they're not hearing from us on that level, and I can tell you from like ESTA standards groups too. Like unless you're sitting at the table, it's completely open. Anybody's welcome to contribute, but unless you go in and contribute, you're just not heard. And then you add a comment of public review, and they're like, we really want to finish this thing, and it doesn't happen. So, and then I think also the other thing I would say in the big picture, I hope something comes of this. I'm probably a little pessimistic about it because I think in our world, you then have to go convince all the lighting manufacturers. Whatever hardware audio decks are left, well, there's a few of those people in the room. That's not that hard. Pyro people and all that. And my guess is that a 3-pin XLR is going to be there a long time. But it would be nice to have a standard way to deliver it to some box that somebody here could make, that then you plug an XLR from that into your thing, and you're not running, an audio DA and a distributalizer and 500 feet of mic cable out over the thing. We got about 5 minutes left. Anybody?
I think it's just a good idea that the lightweight as possible to just go full circle is to actually mention to them what you mentioned to us at the beginning about.
So
let's they're going down this path, trying to make it everything for everybody. Yeah. But just reinforcing from this point of view that I agree. I'm not sure about the room on. Comparing this to ACN or to DMX, a narrow, simple, something that's as lightweight as possible, but just saying that, that's a qualitative request or desire from this industry.
Right, and I think I sort of started this before we started today. It seemed to me like what we would want is a multi-class show clock, right? Which is kind of what we've evolved to anyway. And the issues of resolving, it's good to have people, like manufacturers here and stuff, resolving that to a more precise time base and all is interesting. I'm more looking at it from the user perspective. In the end, we just want a simple way to get this thing out. And it was somewhat surprising to me. It sounds like there's some solutions to do that today. So that may just continue on and expand. But yeah, my guess if they make something hugely complicated, it just will fork off and probably won't be adopted by our industry. So we need something simple. But also you can write a protocol and send it to, or we could do it through the ESTA group if people really want to do this. So, well, thanks. I think this was really interesting. It's great to have all these people here. And if you have ideas for next year, we might, we don't have a venue in Las Vegas. We always have a great venue here in Orlando now. If you have recommendations, we lost all our venues in Las Vegas, unfortunately. So next year, if you know somebody who has a conference room in Vegas, we're happy to do it. We're happy to do the case study thing again. Maybe we do every other year, do case studies one year in some topic the next, because I thought this was really interesting for me. And we're gonna have some kind of video of this, and I'm gonna try to summarize it on a blog at some point in the next month. So I don't know when. Great. Anything else? Jim, anything else? The last thing.
Thank you, John, for bringing us here.
Oh, thank you. It's great.